this video, I'm going to show you how to do a t-test in R software. So I'm here in RStudio. The first thing you want to always do is make sure that you're in the correct working library where your data is. Go to Session, set working directory, and navigate to the correct place. I've already done that here, so I don't need to do anything. The next thing you need to do is read in your data. I have another video that shows you how to do that if you need to know how to do that. For now, to do an independent samples t-test, you're going to use this t-test function. This t-test function is automatically included in R. You don't need to add a package to do it. As you probably know, we have two types of t-test, independent samples and paired. With the independent samples t-test, you're going to use this format here. With this format, you name your data set and you give it $sign and the name of the column, as that's your dependent variable, the interval ratio quantitative variable that you're checking on, okay, that you're comparing. And then you do this squiggly thing, which should be in the kind of the upper left-hand corner of your keyboard. And then you tell it the independent variable that you're comparing groups for, okay? And then you want to tell it whether you are making the assumption that the variances of the two groups are equal. var.equal equals true. If you don't put that in there, by default, it will assume false, that they're not equal. So you have to specify if you want it to be true. I click Run. And you'll see that I get the results down below, the t-test statistic, the degrees of freedom, the p-value, and the alternative hypothesis, which is a not equal, a two-tailed by default. We can tell it to do of just a less than or greater than if we wish to. I'll show you how to do that in a minute. It also gives you a confidence interval and the means for the two groups. Now, of course, you can put this as equal to something, save the results in a particular variable, and then you can, call it back later. Okay, let's just play with some other options here. We can use alternative equals, and then I put it in quotation marks. And let's say that I want it to be greater than. If you're not exactly sure, what you can do is you can go to the help for t-tests. So I'm just going to go over here, help, or I can type in help, or I can just type help, parentheses, t-test, and it'll give me the basic options and so forth that I can use here. So you see for the alternative argument that we put in this t-test function, I can use any of these. So, and by default, it's going to be two-sided. So let's say I want to make it greater. Type that in here. I hit Run, and then it's going to give me that t-test. Okay. Now you can change the mu value here. By default, it's 0. This is, if it's paired, although we set that up a little differently. The variances are equal, which I've already got up here. Confidence level. Those are the different options that I can put in here. Now, let's suppose I want to run a test, a statistical test, to determine whether the variances are equal. In order to do that, I actually need another package. So you need to, if you don't have it already, you need to, under Packages, go to Install, type in CAR, C-A-R, and then just hit Install. Okay, I already have it, so I'm not going to hit Install there. And then, once you've installed it, you need to run it. And then this is the Levine test command. Notice that T is capital in the middle, the L in the beginning is not. And you notice that I've set it up just the same with one exception. The exception here is because in my particular data set, I have coded gender just as ones, twos, and it is thinking it is numeric. It won't do the Levine test. It needs to think it's a factor type variable. I can do that by having my data already be factor, or I can wrap this little command around the variable as.factor to tell it to treat it as factor for the sake of this function. So that's a little difference. It's not necessary here. You could put it here and it wouldn't hurt anything. It figures that out on its own here, but for this particular command it does not. So you've got to hit that and hit run. And then when you do so, you're going to see the Levine's test pop up down below. And you see that it is not statistically significant, so I don't need to worry about doing this, changing this variable's variance dot equal to false in this particular case. Okay, so it's okay as is. All right, now let's look at a pair samples t-test. With a pair samples t-test, you're generally comparing one variable to a different variable, two different columns to each other. And what it's doing with the pair samples t-test is actually subtracting one from the other, okay, and just doing essentially a single sample t-test, testing that the mean equals 0 on that set of differences. And because internally what it's doing is just treating it as if I have this one sample of differences, it doesn't make sense to worry about the variances equal. Okay, that's not something we worry about, whether they're equal or unequal. There's just essentially one sample, this sample set of differences. So we don't worry about that feature at all. And we're just going to tell it paired equals true. I can tell it if I want a specific alternative or use the not equal to default. Hit run. And you'll see, I'll see the mean difference here. I've got my p-value, t, degrees of freedom, and so forth. This negative infinity basically means, well, like it says negative infinity, it's something very low. Okay, we don't know how low. Okay, and that's it to doing simple t-tests here in R.